Hi, everybody. This is detailed notes about the continuous domain and range. So discrete domain and range, we used individual values, notably the dots, and we took the x coordinates, that was our domain, y coordinates, that was our range. Now, when we start talking about the continuous intervals, oops, I just wanted us to highlight domain range for discrete. Now for our continuous, the domain, it's basically all your x values. You start from the left. You work your way to the right. So in this case, the domain, it's all x values that are greater than or equal to 0. As the arrow starts at 0, it goes to the right. But notice how it goes up as well. In that case, that helps us get the range, which would be y such that y is greater than or equal to 0. So it's all our positive numbers because the arrow is not only going from left to right from the y-axis, but from the x-axis, it's going eventually up in the positive direction. And that's the idea with domain and range of a continuous function. You're looking at the arrow or the line from where it starts until where it finishes. So in the first example, with the width, how wide, that's our domain. And our domain starts from -2, but we don't include it, so that's why we have to use a rounded parentheses. And then it goes from -2 to +2, but +2, since there's a closed circle, we use a bracket, we include it. Now for the range, again, we read from bottom, so in this case the bottom value is -1. We don't include it because there's an open circle, thus open parentheses, and we use the less than symbol because -1 will be less than x. However, those x values are going to range from -1. That's actually a y value. I am sorry, I need to fix that at this time. And that's from y is greater than -1, or in this case, -1 is less than y, but it's less than or equal to +4. Now for this next problem, again, look at our width. It goes from -4, we include -4, to -1. Remember, we read from left to right. And then the set interval is -4, less than or equal to x, less than -1. And then our range, again, range, how tall? Look from the bottom. We read from bottom to top. So we notice our smallest value is -2, largest value, +3. And our interval, since it's an open circle at -2, we leave around parentheses. And since this closed circle is at +3, we use brackets. And then our interval goes from -2, so less than y, less than or equal to +3. This next problem, the width, we start at -4. Now it's an open circle, so we have to use around parentheses. And then we have an open circle at +1, so we also use round parentheses. And our set interval is from -4, less than x, less than 1. Now, for the range, even though we don't see an open or closed circle, since it touches the y equals -4, y equals -4, that will be our lower boundary for our interval for the range. And we will use a square bracket for the -4. However, notice at the height, it ends up y equals 0, but in both cases we have open circles. So 0 gets a parenthesis, and then our set y such that -4 is less than or equal to y, but it's strictly less than 0. Now for the width, for the next problem, it goes from -3 to +2, but notice -3 is an open circle, so we have round parenthesis in a less than symbol, less than x, but then for +2, close circle, so therefore we have a bracket, and we have a less than or equal to symbol for +2. And for this problem here on the right, we start at 0 because the graph touches the x-axis, so y is 0. Therefore, we have a bracket, 0, comma, and it's only 3 units high, so 3 is our upper boundary, and we have to use a parenthesis because it's an open circle. So we get close to 3, but we're never going to truly touch it. And then our range will be from 0, less than or equal to, because of it's touching the x-axis, +3, but it's less, just a less than symbol because this is an open circle. These next problems, now we're going to get the infinities. So for instance, the width, see the arrow? Notice how it has an arrow sign? This line technically goes on forever and ever. So we go all the way to the left, and even then we don't stop. So therefore, that's a negative infinity. That for the interval, because we start at negative infinity, it's going to be that whole range from negative infinity up to, but not including +4. Open circle, don't include. That's why interval, both ends are parentheses, because we never touch negative infinity, and we're coming from negative infinity to +4, but we don't touch +4 because of the open circle. This case, our set builder notation is all the x's such that x is less than 4. Now for the height, notice how the arrow is going up from +1. So even though the arrow is going to the left, the height, it's going to go up forever and ever. So in this case, our interval will be from +1, which is a round parenthesis because of open circle, to +infinity, because for the range, further we go up, we don't stop, and it's +infinity. And our set builder notation is all the y values such that y is greater than 1. This next problem, similar to the previous problem, we see an arrow, but this time it's going to the right of x equals -3. So this is our x value. This is the point -3, comma. That should be a -2. I will fix that momentarily. For the interval, boom, there we go. We are good. So our interval for the domain goes from -3 all the way to +infinity. We don't stop. So the set builder notation is x such that x is greater than or equal to -3. Now our range, since it's a single line, our range will just be y equals -2, because throughout the whole time that line goes from forever and ever to the right from -3, the only value in the range would be y equals -2. So our interval in this case is just -2, but we just have a single. So it touches only -2. So we're going to have closed brackets, but only for -2. Okay, so now we're on the next page, and we have so we have our domain and range. So in this case, our domain, again, we read from left to right, and we notice that this arrow basically goes to negative infinity, or it comes from negative infinity up to, but we don't include positive 3. So our domain would be all x values such that x is less than 3. Now for the range, the height, so it goes from negative 3, that is our low point, but we include negative 3, so we have a bracket, and it goes up forever and ever, being that even though it looks like it stopped only at x equals 0, but remember, this line here, it's going to make this go on forever and ever. So yeah, it looks like here at y equals 0, the function stopped, but notice the other side of the function. This is going to go forever and ever. So that's why our range for this problem is from negative 3 up to infinity. And in this case, it should be, I'm going to change this symbol from a strictly less than to a less than, or I mean a greater than or equal to sign, because we are touching y equals negative 3. Okay. Next problem. In domain, we start at x equals negative 1, and notice how it goes on forever and ever. So and this, since it's a solid circle, so we start at x equals 1, and this function at negative 1, and the function will eventually go forever and ever to the right. Now for your range, notice how the lowest point of this function occurs when at y equals 2. That's right here. But this function is going to go forever and ever up this way. So our range is such that y value is such that y is greater than or equal to negative 2. And that's what we need for the range for this one, because since even though it goes to infinity, it's never going to stop. So we just need the starting point. Next problem, notice how this function, the arrows go forever and ever. So even though it looks like a stop, but they're going to go forever to the left and forever to the right. So the x value is basically all your real numbers. That's your x value. It goes from left to right, and it never stops. Now, the y value, on the other hand, that's a different story. Notice how at y equals 3, that's the highest point for this graph. So we're going to read from bottom to top. Now, again, the arrows go forever and ever down. And since we read from the bottom to the top, it'll be negative infinity to positive 3. That's our range. And for the set builder notation, it's such that y is less than or equal to positive 3. Because the highest y value for this particular graph is at y equals 3. The next problem, similar to before, function goes forever to the left, to where we don't know. Somewhere that this one goes forever to the right. Oops, I don't want to do what I just did. and put some dashes. Let me, in fact, get rid of that. I just want it more. So we see, oh, this goes on forever and ever. So our domain, similar to the previous problem, it's going to be negative to positive infinity. Now this symbol here, I forgot to mention in the previous problem. This set interval notation is x such that x is an element in the real number system. That's how you translate that x. Looks like an E with a fancy letter R. That E looking symbol represents is an element, and this R, the fancy R, is the real number system. So this is, in both cases, x such that x is an element of all real numbers. And then for the y here, whoops, I made a little bit of a boo-boo. That should be, since y is, the lowest value for y is 0, that means all of the values, since the lowest possible value is 0, our range is such that y is greater than or equal to 0. So that's the range for this problem. The lowest value takes place when y is 0, and this arrow goes up forever. That one will eventually go up forever. So our range will be from 0 to positive infinity. These last two, in both cases, the domain will go forever and ever, so the domain's never going to stop. The range will also never stop. So the domains in both cases, the last two, it looks like the arrows look like they're going to stop, but they go on forever and ever. And the range similarly, that's going to go forever and ever. Both from y equals 0 down to negative infinity and y equals 0 to positive infinity. So our domain and our range for this problem and this problem are both all real numbers. So in the case where your domain or range will be all real numbers, you would write either x such that x is an element of all real numbers, or y such that y is an element of all real numbers. That's the case for both of these last two problems, because in both cases, this function starts somewhere to the left. We don't know. And it's somewhere way down yonder. We don't know. And for this one, goes up and to the right, and that's going to go forever and ever. Similarly, this one starts somewhere on the left, but somewhere way up high, and it ends to the bottom, but it keeps on going forever and ever and to the right. So it starts from the upper left, ends at the bottom right, but they go on forever and ever. So again, domain and range for these last two problems are from negative infinity to positive infinity. Your x is such that x is an element of real numbers, y such that y is an element of real numbers, because again, it could be any real. This function eventually will touch any x value or any y value. It may take a while, but it'll touch.